Hi everyone, welcome to This Week in Space Science. I'm Michael Baltimore, your host here on Twiss, and of course, Dr. Sean Cruzen from the Coca-Cola Space Science Center.
Hello,
Sean,
Mike.
Welcome to another episode here in the studios at Columbus State University, and we've got a very special show again today. I can't wait to get into this. So it's good times here, ladies and gentlemen. You're watching us in various ways. Perhaps you're watching us on CSU.TV, ColumbusState.TV on the web, on your Roku player, on iTunes, and other places, and of course MediaCom channels 99 and 98 here at in Columbus, Georgia. We're at Columbus State University, and we welcome you to this show. Sean, we have some exciting news to start off the show with. We have to go there because this is a topic that we've talked about quite a bit on this show, and I'm really interested in what you're going to tell us today.
Well, it's a fascinating thing, and you know, a lot of times when we do topics on the show, I try to make them timeless because, again, as Mike just said, I'm not sure when you're watching this or in what form of media. We hardly ever go with breaking news, but this literally is breaking news, and I'm going to go ahead and throw out the date. So today is April the 17th, 2014, and that is the day of a very major announcement by the National Aeronautics and Space Administration and a team of scientists from a multitude of universities who are working with the Kepler Space Telescope. Today, ladies and gentlemen, has come out an announcement that they have now found the very first ever extrasolar planet, in other words, planet orbiting another star that is both roughly the same size as our Earth and in that very special place that we call the habitable zone, the place where the temperatures and pressures are just right to make that planet capable of supporting liquid water on its surface. And that planet is called Kepler 186f. And today, just literally minutes before I came up here to the studio to film that show, there was a press conference going on at NASA, and they were revealing some of the details about this brand new discovery of a new, what we call exoplanet, that is in the habitable zone and roughly the size of the Earth. So Mike, they finally found another Earth.
Well, you know, we've talked about this before, and there were thousands of planets, what, 1,500 or so, that I remember you reporting on. And this notion is, most of the time, those planets are much bigger than the Earth.
Exactly.
And so this is very different, that it's close to our size and in the same orbital distance, perhaps, from the star. I want to hear more about this.
Well, so let's first of all talk about the Kepler Space Telescope, because that's a good place to go. Now, the Kepler Space Telescope is a telescope that's designed to hunt for planets that are orbiting a distant star that happen to have a very particular alignment. And you can see kind of in this artist's conception in the upper left-hand corner of your screen, you see a star with a white ring around it. Well, the white ring is fictional, but what they're showing is on that white ring, there's a little black dot, and that's a planet. That's a planet orbiting some distant star in this kind of cartoon drawing here. And what happens is that planet is its orbit is aligned just right to where that planet moves in front of the face of that distant star. And the Kepler Space Telescope is designed to identify stars with these planets moving in front of them. And then once identified, the Kepler can measure the parameters of that planet's pass in front of that distant star. So in other words, they can figure out about how long it takes to move across. They can figure out about what its diameter is because they can figure out the percentage of light that is blocked as that planet passes in front of that distant star. And from that set of data, the scientists on the ground are able to say, yes, this is an exoplanet, or no, this is something else, some of the kind of phenomenon taking place on that distant star. So through that technique, which is called an occultation or a transit technique, then the scientists at the Kepler Space Telescope have been able to identify, as you just said moments ago, over 1,500 candidates for planets around other stars. And so they're able to say with some certainty that there are that many known exoplanets orbiting stars that are not our sun, other stars in our own Milky Way galaxy. Now, Kepler can't see this phenomenon taking place in other galaxies. It's only looking at stars more or less in the neighborhood of our own sun, at least in terms of the overall size of the Milky Way. The Milky Way is 100,000 light years from one side to the other. And so the stars that we can see with this kind of level of detail really are in our own neighborhood within the Milky Way. The star that we're talking about today with the habitable planet is about 500 light years from the Earth. So on that scale of 100,000 light years, 500 light years is right here in the backyard.
Yeah.
It's in the very near galactic neighborhood within the Milky Way galaxy. And that's what makes this such a very special and important discovery.
Well, it is an important discovery and very exciting news. You know, we talked about this, you use the phrase Goldilocks zone, the distance from the star to the planet and its orbit there.
Yes.
And I assume that we've started that from our measurements of our own solar system,
That's
from
exactly
the Earth to
right.
the Sun, and then we apply that into any of those exoplanets out there and their stars.
That's exactly right. We have to take what we know about planetary science and we have to start with our own solar system, because that's the one that we can study in the greatest detail, because it's the one that's right here. So we can get the best measurements of how starlight from our sun interacts with the planets and their atmospheres at various distances in our own solar system. Those become the hinge pins for modeling how starlight behaves with an atmosphere of various sizes of planets at various distances from their various parent stars. So we use our solar system as that basis for our understanding, the basis for our modeling of what conditions might be like on these extrasolar planets. And then we scale the starlight up and down depending on the nature of the parent star.
Right.
So if that parent star is much larger than our sun,
Yes,
or
that's
much
a good
hotter
question.
than our sun, then it's going to be putting off a lot more intensity of light, and that changes the intensity of light reaching that exoplanet. If the exoplanet is either much farther away from its parent star than we are from the sun, or much closer to its parent star than we are from the sun, then we have to take those factors into account too. And all of those things I just said are a very important part of the story in Kepler 186f. Because you see, that parent star is a star that happens to be a whole lot smaller than our own sun.
Oh, okay.
It's a much smaller star, it's putting off much less radiation, and therefore, that planet that we're talking about, Kepler 186f, can be a whole lot closer to its parent star than Earth is to our own sun, because that star is smaller and cooler. Now,
that's a nice diagram right
it's
there,
a great
too.
diagram.
Kinda shows
This was part of the material being put out by NASA today, and so we can use this material to show the configuration of this solar system. So first of all, if you look in the upper right-hand corner, you're going to see a little disc with some white lines through it and a green ring. That is a representation of this alien solar system. Their parent star is the star that's in the middle of all those circles. The circles that we see there are the orbits of other exoplanets in that solar system. And then the biggest circle there that's out toward the edge of that green ring, that is Kepler 186f. Now, why is it called F? Because A, B, C, D, and E have already been found. So there were already 5 other known exoplanets in the system. F was the 6th one to add to that. And so this is the 6th known planet in that solar system. And it just happens to be at that distance from its parent star that's about equal to the distance of Mercury from our own sun. Now, if you look down to the lower part of this diagram, that's a schematic to the same scale of our own solar system. So you can see that Kepler 186f lies at a distance from its parent star roughly equal to the distance that Mercury lies to our own sun. And again, you might think, well, wow, Mercury's really hot. And its surface is being cooked by this, at least the one facing the sun, by that intense radiation coming off the sun at that very close distance. And that's true, but remember, our star, our sun, is a whole lot hotter because it's much bigger than the parent star of Kepler 186 and its system. And so that Kepler 186 star is just smaller, it's not putting off as much radiation. Now, let's pay attention to those green rings in this diagram for a moment. Those green rings represent what we called the habitable zone, or as you mentioned a moment ago, the Goldilocks zone. We call it the Goldilocks zone because it's not too cold and it's not too hot, it's just right. It's just right set of temperatures to allow temperature pressure conditions on a planet to support the presence of liquid water. And when we look out into these exoplanet systems and consider whether or not they might harbor life, it's always life as we know it is what we're thinking through. And life as we know it requires the presence of liquid water. In fact, it almost mandates, the presence of liquid water almost mandates that life exists, as you know, as far as we can tell.
Right.
And so it's an interesting set of parameters to look at. So within that green ring, any planet that would be at that distance from its parent star would support life. Well, let's look at our own solar system at the bottom. And you see Mercury way too close to our sun. It's too hot. It can't support liquid water. Venus just inside the green ring. Mm-hmm. But yet that small distance just inside the green ring tells us that conditions are not right for liquid water there. In fact, it's a little bit too hot. And as we know, Venus, one of the hottest planets in the solar system, has the highest surface temperature in the solar system because it has a tremendously thick atmosphere and traps all that heat from the sun. Part of that was because it formed at that distance close to the sun in the first place. Right. So it's outside the habitable zone. In fact, the only star in our habitable zone in our solar system is our Earth, right? So even Mars would be too far. It would be out beyond this green ring and be too cold. So Earth is in the just right location. Well, let's take that knowledge then and extrapolate it up to Kepler-186 and its system. And look where F is. Kepler-186f, sitting very near the outside edge of the habitable zone. What that means is this could be a winter planet. You know, it's in that zone where water can exist on the surface, but it's out at the outer parameters of that. And so therefore, there's liable to be, if there's water at all in that surface, there's liable to be some of it that's frozen. But still, conditions exist where liquid water could be present. So if this planet's going to lean one way or the other, too hot or too cold, this one's going to lean a little bit toward too cold.
On the cold side, yes.
Yeah, it's going to be a little bit on the cold side. So it's out of, but yet it's still inside that parameter of the habitable zone. It's toward the outside edge, a little bit too cold, but probably still could support amounts of liquid water. So that makes this a very interesting system. Potentially gravitational conditions similar to the Earth. Notice in the diagram in the upper left, the inset, it's a slightly bigger planet than the Earth. It's close to the same size as Earth, but it's slightly bigger. Yeah. And if it's roughly the same mass as the Earth, that might mean it has more gravity. Now, we don't know these things right now, but if it does have more gravity, it might hold a little bit thicker atmosphere. If it holds a little bit thicker atmosphere, it's better at this process called the greenhouse effect for trapping heat, which could warm it up a little bit more. So maybe it's not quite so cold there because it might have a little bit thicker atmosphere. Now I'm layering on conjectures here. We don't know any of those things, but those are the kinds of questions now that planetary scientists will begin to ask about Kepler-186f. And they will do a variety of models simulating the conditions and what they would be like, both gravitational conditions and atmospheric conditions, along with the heat model from that radiation coming in from the parent star.
Okay, there's an artist's conception. So right there.
Exactly. We are seeing what
almost a point of view, as they call it.
It's a point of view shot. Exactly. We are seeing what this planet, what the surface conditions might look like. If you see the star, notice it's red, and again, it's an M dwarf. M is a classification for stars in what we call the stellar spectral classification system. M is the coolest of all the categories of stars. It's the smallest, it's generating the least fusion, it's putting out the least amount of energy, and so it is among the coolest stars. That's why it gets that kind of reddish color. Right. A lot of people think, well, it's red hot. Well, it's hot and it's red, but red is the coolest color among star colors. Blue is actually the hottest of all the star colors. Okay. And so this is one of the cooler end stars. Again, a kind of a cartoon view here in a sense of those other planets that are in the system right there, in between this planet and its parent star. And yes, well, apparently we're high in the trees.
I like the trees. I like the effect that they put the trees on there with the water and the, the little, incoves and some other things there. But what got me, my first attention was drawn to the fact that there's a Milky Way.
There's the Milky Way. It's
right
the same Milky Way that we're in.
We're in the same place.
Yeah, it's part of our own Milky Way.
Not that far away in those vast terms that we talk about.
No, it's, again, as you say, it's very close to us. It's right in our neighborhood. So it would see a view of the Milky Way reasonably similar to what we would see because it also is a long way from the galactic center. But this is again a conjecture, of a lake with possibly these alien trees and things like that. We don't know those things, folks. We don't know whether it has water or not. We don't know whether there are trees or not. But it could look something like this, and that's really the intriguing part. This could be a location for, number one, liquid water, number two, on a planet similar in size to Earth, and number three, if those conditions exist, conditions might be right for the existence of some form of life on this weird alien world, Kepler 186f, right here in the galactic neighborhood.
Right. Brand new announcement about this, 186f from Kepler. Pretty amazing. So the idea of water on the planet is I mean, that's hard to identify out there, basically. So we're looking at that habitable zone and kind of using that as the predictor of possible water on the planet. We can't read that in infrared or some other scientific way from some other telescopes about water on these planets that far out.
So here are the set of difficulties that are involved. We cannot yet make a direct measurement of surface conditions on that planet. We would love to be able to do that, but things are farther away in our universe than we can really imagine, than we really grasp. So when we say 500 light years, every one of those light years, one light year, 26 trillion miles. So it's a ridiculous amount of distance. So each one of those light years is a crazy distance, and there are 500 of them out to this particular object.
Right.
So there's no way we're going to be able to make a direct measurement. We don't have any instruments sensitive enough to make any kinds of direct measurements of the surface conditions. Now, if we get lucky, we might be able to get a spectrum of light shining through the atmosphere of that exoplanet. Remember, it's passing in front of its parent star. A spectrum means we let that light go through a prism and we break it up into its component colors, and there are features in that spectrum that allow us to identify various chemical species. And so we might be able to pick out the fingerprints of various chemicals that are in the atmosphere of that planet after the starlight shines through the atmosphere and comes to the Earth. So possibly some atmospheric measurements.
Right.
It's not completely out of the question that someday, or maybe someday not too far in the distant future, we could get a spectrum of the atmosphere that might actually show water vapor. Now, if there's water vapor in the atmosphere, does that mean there's water on the surface? Well, not necessarily. So there's a lot of questions to ask there. But you see how we have to kind of stack on these extrapolations. It's not like we're going to know right away whether or not this particular exoplanet does have liquid water on its surface. But it's intriguing for us to be able to identify that very first Earth-sized planet that at least has the possibility of water on the surface.
Right. And there's so many planets, so many stars out there, so many orbiting solar systems out there.
Yep.
But this is the first one we found that's that size and that right distance. It's a pretty amazing discovery.
Here's another couple interesting facts about this planet. So the parent star for this planet, an M-class dwarf is what we call them, that star is a much longer-lived star than our sun. In other words, that M star's lifetime is maybe 10 times the lifespan of our own sun. So this could be a star that's been around for a tremendous amount of time, or that will be around for a tremendous amount of time in the future. Let's extrapolate it backwards. Let's say it's a very, very old star. It's going to be stable in a stable configuration for a very long time. That means that this planet may have been around for a lot longer than ours and have a lot more time for biological processes to take place on the surface of that planet. So that's one potentially interesting thing about it. Here's another thing. Those M-class dwarfs, they're a little bit more unstable in one sense than our sun. They tend to have more powerful solar flares. And since this planet is both closer to its parent star and then the solar flares on that star, at least it's thought by models right now, those flares can be more powerful. This planet can be getting really healthy doses of radiation. You might say, oh, well, that's potentially bad for life. Well, let's say somehow life got going on that planet. Those doses of radiation might actually cause more mutations to occur in any biological systems that can be present, which might speed up the changes of those life forms on that planet and cause changes that happen more quickly to allow development to take place more rapidly. So that's another interesting factor. So do we know any of that for sure about this planet? No, we don't. But we're looking all the possibilities right now, and we're trying to add up all these pieces to say, is this a place where life might exist? Because that comes back to our most fundamental question that we often ask when we look up into the night sky, which is, are we alone? Are we the only living creatures out there in this universe, or places where life can exist at least? And more importantly, are we the only intelligent living creatures? Are we the only ones looking up at all this and wondering whether or not we're alone? Well, it's not out of the question that there are critters on that Kepler 186F doing the same kinds of things and asking the same kinds of questions. Right. Not out of the question. Not likely, and I'm not saying it's so.
Okay.
Not out of the question.
All right, stay tuned.
Very, very interesting stuff. Yeah, we'll know next show. I'm sure next episode we'll be able to answer all those questions.
All right,
in detail.
No, this is good science, though. We need to look at these and look at the possibilities of things out there in that way, and that's why it is so exciting to hear this kind of news. And thank you, Sean, for bringing that in today. Now, there's been some events here recently that you wanted to talk about, so introduce it.
Well, we had something kind of fun that took place over the heads of our folks at the Coca-Cola Space Science Center here at Columbus State University and our Midwest Vaco Observatory. We do a program that we call webcasting. We have our observatory that we have set up to do webcasts of celestial events, and we do those quite often, a variety of phenomenon. A very interesting phenomenon took place in the nighttime sky just a few nights ago, and that was the first of 4 lunar eclipses that are going to take place in successions of 6 months. So this is a tetrad of lunar eclipses.
I remember you mentioning it on a previous show.
Just about the last episode we talked about this a little bit.
And it will be quite a while after this, before that occurs.
Yeah, it'll be a very long time before a 4 eclipse year, or a set of eclipses within a year and a half take place. Now here's the interesting thing. We had planned to set our telescopes up, take images, live video of this event, and feed it out to the world. We put an advertisement on the website of our good friends at spaceweather.com. They have a very highly visited site, and so we had lots of folks visiting our website, and we had our web stream set up, but this is what took place. Rain.
Oh, yes.
Rain, and lots of it. We had a very major set of thunderstorms roll through the southeastern United States on Monday night and into Tuesday morning of April 15th, tax day 2014.
Bad timing.
And it kind of swamped us out. But but my staff, and that's why I want to tell the story because it's an interesting story, they did something that was very exciting.
Okay.
They went online and they were taking emails. By the way, that's an all-sky camera. You can see all those clouds over the head of the observatory at our location. And certainly that was not going to be a good night to observe anything except rain. Okay. But our folks, Dr. Rosa Williams and the team, were at the Space Science Center. They were taking email questions. They were answering them on air through a microphone system where we could actually speak directly with our audience who was watching the webcast. We happened to funnel in a video stream from the University of North Dakota. They were having clear skies, so we were able to provide some live images of the eclipse taking place. Okay. And that was through a connection with Dr. Andy Puckett, who was one of our astronomers here at Columbus State University. He had some friends up there at University of North Dakota. A shout out to them. Thank you very much for providing your web stream. But our folks who were running the program, Michael Johnson and some of the other guys who were there, they had an interesting idea. They said this. Over the microphone, they said, hey, if you're out there and you're listening to our webcast, if you got a good picture of the eclipse, why don't you send it in to us? They thought maybe they'd get 1 or 2 pictures, from people who maybe were actually photographing the event. Well, something very fun happened. Literally hundreds of people from all over the United States of America, from places like UK and Canada, they began to send their images into our observatory by the dozens. And these images ranged from everything from kind of blurry cell phone pictures all the way up to some very professional looking imaging taking place right here. We've assembled those into a video, and the video you're seeing here on the screen right now is just kind of it's a camera roll, if you will, a slideshow of all these pictures that we were sent in. And it's just kind of a fun thing, because here's what happened. When people started seeing their own pictures appearing on our webcast, everybody got excited, right? And
Right.
and when
Yeah,
people
of course.
started seeing other people's pictures, well, they wanted to send pictures in too. And all of a sudden, you had people from all over North America, from the UK, from Canada, sending images into our observatory, commenting on each other's images.
Bellevue, Washington.
There's
up
Bellevue,
there
Washington. That's a
with the,
beautiful picture
that's
right there.
Great, huh? Very
And
artistic.
here again, it didn't take any specific equipment. People were just using their cell phone, but people were sharing in this event. And I really think that's the power of this whole new media movement that we're
I think
seeing,
so too, yeah.
where people are communicating online, real time. That's the essence of our real-time observatory, where we're doing these webcasts, is so that we can make these kinds of things happen. We have the equipment on board at our observatory to be able to speak to our audiences over our webcasts and get them to interact with us. And that resulted in this very cool event. Now, let me just say, as you're watching these beautiful images come in, that a total of 48,000 unique viewers logged into our webcast that night. Remember, it's raining here.
Yes.
Right? So we had 48,000 viewers from 159 different countries, from over 8,600 different cities around the world,
Goodness.
logging in and watching the webcast. We did a little bit of web statistics to find out those numbers. One of the other web stats that we noticed was they were staying. And the reason they were staying is because they were seeing this very cool phenomenon of all these people sending in their photographs, and we're showing you now. The average stay time on our webcast was an hour. So they
that's
were
pretty good.
they were hanging around
Yeah.
and really watching the webcast. They were
people's
sending in their
attention
questions.
span, yes, that's
They were listening to the answers. That's a very beautiful photograph,
that's
by the way.
nice.
That came from a gentleman in the UK. Lovely photograph of a setting moon. You could actually see the atmospheric distortions. Here's another great shot of the eclipse from Houston, Texas, Memphis, Tennessee. Again, people all over America and some outlying regions sending stuff in. Really cool phenomenon. Again, the power behind this, people got to interact, not just with us, but with all of the other people watching this webcast, which is a very large audience, for an event like this. And so we were very excited to be a part of
think
this.
it's great, yeah.
And we wish we could have provided our own images of a webcast, or of this eclipse rather, but we just couldn't do it because of the rain. But we were able to facilitate all kinds of people getting together and using our site as a hub to do so. And it was very, very fun.
I like it a lot. And this new media, this interactive media part of what everybody's moving to right now, you guys actually demonstrated that, and it was a wonderful reaction from others. They started sharing together. They stayed on the website watching this and looking at others as well. I think that's a wonderful experience.
It really is a neat experience, and one of the cool things about it is it makes you feel in touch with all the other people who really think the same kind of stuff is cool.
Yes.
Right? So it's all the people out there who really like astronomy and just love nature, basically, and wanted to somehow take part in it, interact. And this setup allowed them to do it. We didn't anticipate necessarily doing this part of the program, but it kind of organically evolved, and it was a really fun thing to be a part of. So one last thing I'd like to show you is you're watching some of these images come in. Some of those better images where you can see some of the color, I want you to look for kind of a turquoise shading to the moon. And lunar eclipses are red because as the light shines onto the Earth, some of that light gets through Earth's atmosphere and hits the moon, and that's why the moon turns kind of red in color. Earth's atmosphere is very good at scattering off the blue light, so only the red gets through. But on some of those images of the moon, you might see kind of a bluish or almost turquoise stripe. And that's because in the upper layers of the atmosphere, particularly in the upper stratosphere, there's this substance called ozone. And ozone actually does a good job of absorbing red light and allowing blue light to get through. So where we had mostly an orange moon because of the natural Rayleigh scattering taking place in Earth's atmosphere, we also had this effect from the stratosphere of kind of a blue hazing around that. And you can actually see that on some of the images that were sent into us from these astrophotographers around America. So that was kind of a cool thing too. Well, another thing that tells scientists is that the stratosphere right now happens to be very clear. In other words, it's free of volcanic dust. There you can see on this picture right here, that very bluish ring just to the edge of the white right there. Very clear indication of that very clear stratosphere. If a volcano happens somewhere in the world, or if debris, here again you can see that turquoise color. If debris is thrown into that upper stratosphere, you won't see that, because what'll happen is that stratosphere gets filled with this dusty material, which is very good at absorbing out those short wavelengths of light, and it gets kind of red again. In fact, the moon can get very almost blood red, dusky red. But in this case, a very clear stratosphere led to a very kind of blue hint to some of those lunar photographs.
Very interesting. I'm glad you explained that part to it. They had the very orange, dark orange, and then with this blue.
Hint of blue in this photograph here again, right? You can see it there. So again, thank you to all the people out there who took part in this webcast. And listen, you really made it, right? So our folks here facilitated, but all of you out there who sent in photographs, you're the ones who really made this webcast unique. You made it a special media event on our computer media. You made a great webcast for each other. And I think that may be the most interesting thing about it to me, is just that phenomenon that kind of organically grew out of this event.
I like it, and those pictures continue there. All right, so that was a great experience.
It was
fun. All the clouds and the rain, it was torrential rains down here at that point.
You know, astronomy in the southeast, it's maybe not the best observing location, but that's where we are, so we do the best we can.
There we go. And you made took those lemons and made some lemonade on that.
We
I
tried.
think that was great. Well, congratulations to your
you.
group down there for pulling that off
Appreciate
as well.
that.
And using the latest technology to make things happen. All right, you have a couple announcements too.
Yeah, I just want to give here to close out the show, I want to give a couple of shout outs to a couple of our students here at Columbus State University who are students in our Earth and Space Sciences department. They are astrophysics and planetary geology majors, and the two of them have been doing a phenomenal job in a variety of circumstances. One of these two gentlemen, Cameron McCarty, was in on this lunar eclipse webcast, so he was staying up all night helping to facilitate that imaging and the sharing of those images. But there's a couple of gentlemen I really want to give a shout out to because they've had some very major accomplishments, and I want to talk about those.
Sure.
The first one of those is a student by the name of John Hood. John Hood is a graduating senior. In fact,
Thanks, John.
Next month he'll be graduating. He's on the right-hand side right here. He's standing next to astronaut Dr. Bernard Harris, who happened to be visiting Space Science Center there a year ago.
Yeah, it's
yep.
great.
So that was last year. They're standing in front of the Space Shuttle main engine nozzle in our exhibit gallery right there. But John Hood was just named the Columbus State University Student Employee of the Year.
Yes.
Now there are literally over 100 student employees on campus. Over 27 of them were nominated for this award, but because of John's massive contributions to our observatory and all the great work that he's done here at Columbus State University, he was the one picked, not by us, not by those of us who are prejudiced, but by the good folks at Human Resources, based on his resume, to be the Student Assistant of the Year, and we are just extremely proud of John.
All right, congratulations, John.
John has a great future ahead of him. He's actually flying off next month down to Australia. He's being interviewed for a PhD program in radio astronomy down in Australia, and we wish him all the best of luck on that. So that was one of the acknowledgments we want to give out. The second one is for Cameron McCarty, who I just mentioned a moment ago.
Yeah.
I think we have an image of Cameron here. This was another webcast. This was Cameron in Australia preparing for a solar eclipse webcast, rather, that took place last year. He's actually at an Aboriginal school there. He's showing kids the sun through a hydrogen alpha telescope, a safe telescope to look at the sun. These kids had never even seen a telescope before.
Okay.
And here is Cameron out in the middle of the bush in Australia, sharing that technology with those kids for the very first time. A really cool experience.
No telling what that kid's looking through the telescope's going to do with that experience and how it might change his life, you know?
We would love to
Great
think that
things.
we're inspiring the next generation of astronomers and engineers in Australia as well, right? So that's a really cool thing. Cameron McCarty was just selected for a summer internship at the Marshall Space Flight Center. This will be his second internship. This summer, Cameron's going to be actually analyzing samples from the lunar surface in the Lunar Planetary Lab at Marshall Space Flight Center. So that's fantastic work. Cameron was also selected to represent all of the intern program for all of the NASA centers. He was selected as just a handful of students to go to Washington, D.C. on behalf of that program and represent that program to the legislators in Washington, D.C. So Cameron, fantastic work, buddy. You've done a lot of amazing stuff here at Columbus State University, and I am tipping my hat to you guys right now. Cameron and John, two of our very greatest students, but we have a lot of other great students in that program, and you'll be hearing more about their accomplishments in coming shows because we just couldn't be prouder of this crop of students who are moving through the Earth and Space Sciences, Astrophysics, and Planetary Geology program.
Oh, that is amazing, and hats off to those guys for doing such a wonderful job. And they're getting a great experience here at Columbus State University in your department. And the Coca-Cola Space Science Center is always doing something wonderful and amazing and helping us learn more about space science.
We acknowledge the support of all the folks from the university and also the faculty members involved in Earth and Space Science, all of the geology, environmental science, all of the faculty in that department, physics faculty. Everybody's contributing to these wonderful programs, and Space Science Center is just playing a role in that, and I'm tipping my hat to all y'all out there. So.
All right, sounds good. And that STEM initiative, too, I think you had something to do with that. We want to thank you, ladies and gentlemen, for watching This Week in Space Science. It's been another Twiss. Dr. Sean Cruzen, Executive Director of the Coca-Cola Space Science Center here at Columbus State University.
Thanks,
and
Mike.
Thank you, Sean. And we're glad that you're tuning in. Watch us each week right here on Columbus State Television, CSU.TV, on the web. We'll see you next time.